Hello, today we are going to look at practice problem 7.7. The target for 7.7 is I can analyze a system of equations and determine what the better deal is. So if we take a look at our scenario, you want to join a swimming pool in the summer. You check out 2 different pools and find the price of each pool. Dormont Pool charges a one-time fee of $70, and each time you go in, it costs $3. And Bower Hill charges a one-time fee of $125, and it only costs $1 each time you enter. So we're asked to write equations for both Dormont and Bower Hill pools, and we define the variables for us. X represents the number of times you go to the pool, and Y represents the total cost. So hopefully you can think about, well, what form would these equations best be in? Well, if there's a one-time fee for both, they should probably be in y equals mx plus b form. The b being that one-time fee. All right, so Dormont is D. Let's take a look. Y equals, right, our total cost equals our constant rate, and our constant rate is $3, so we have 3x plus that one-time fee, which is $70. Bower Hill, y equals that total cost, remember? So total cost equals the constant rate, which is $1 each time. We're just going to write x. You can write the 1 there. I know a lot of you do like that. That's fine. But I'm just going to leave it as x. Plus that one-time fee, which is that $125 sign-up fee or one-time fee. Now that we have the system, we can take a look and find, for each pool, determine the number of times you must go in order for the cost to be the same. And then how many times will that be, and what will the cost be? All right, so in order for them to be the same means equal, we can solve this system by using substitution. Since we have an equation with one variable, or in this case we have 2 variables, I can substitute 3x plus 70 in for the y in my second equation. All right, so we have 3x plus 70 equals x plus 125. Let's get those x's together, but again, we can't just jump across the equal sign. I want to algebraically move this 1x and subtract them from both sides. They cancel out. 3x minus 1x is going to leave us 2x. Plus 70 equals 125. Now I want to take a look at some like terms together. I have 70 and 125. They want to be together, but we have to algebraically move the 70 by subtracting. All right, so now I have 2x equals 55. And finally, I want to get x by itself. Remember, 2 times x, well, the way you undo that multiplication is you divide. So x equals 27.5. All right, I know you're probably saying you can't go to the pool half times, right? 27.5 times. Well, that'll be part of our explanation, but algebraically, that is exactly when the costs will be the same. So now that we know what our x is, let's go and find our y. Just plug it into either of my equations. Bower Hill may be a little bit easier because we only have 1x. So we have y equals, I'm going to substitute 27.5 in for x plus 125. And y equals, when I add those 2 together, I have 152.5. But we know it's money. We better add that 0. Okay, so $152.50 is going to be the cost for both pools when we go 27.5 times. So our solution is 27.5, 152.50, which means that's the point that the 2 lines will intersect on the graph. All right, so what does that mean? All right, when are each of the pools the better deal? Right, if you know in the summer, if you're traveling for 3 weeks, are you really going to get to the pool 27 times, 27 and a half times? Or let's say you're not going on vacation, you're not traveling at all, and you're going to plan to go to the pool every day. Well, which pool should you join? So, explain when each of the pools is the better deal. Remember, there are 3 parts. Our first part, we can explain what this solution means. If I go to the pool, exactly 27.5 times, which remember can't really happen, my cost would be the same, which is again $152.50 for both pools. All right, so that's our first explanation, right? Okay, so if you're going to go to the pool, well, 27 and a half times, you're not going to be able to go that many times, but so let's say 27 times. If you're going to go 27 times, which one is better, 27 or less times? Take a look at the system, and I'm going to erase some of my green markings here. Less than 27 or less times. Well, look at the one-time fee. So the one-time fee for Dormont is $70. Remember, that's what you have to pay before you even go to the pool. And the one-time fee for Bower Hill is $125. So if you're going to go fewer times, this pool is going to be less expensive. You're only going to have to pay $70 as opposed to $125. So the second part is, if I go less than 27 times, or if I go, let's call it, if I go not less than 27 times, if I go 27 times or less, Dormont is cheaper because it has a lower one-time fee. And then my third and final part is if I go more than 20 or 28 times or more. Remember, 27 and a half is where they were the same. So you can't go to the pool half a time. So round up, right? If I go 28 or more times, that's when Bower Hill is going to be less expensive, because although you have a higher sign-up fee, each time you go is only going to cost you $1. So if I go 28 or more times, Bower Hill is cheaper because even though it has a higher sign-up fee, the daily fee is less. All right, the daily fee being that $1 versus the $3 each time you go for Dormont. Okay, I hope this helps. Make sure you make any corrections to your work, and I hope to see you all soon. Bye.